Hi everybody, and welcome to Activity 5, Lesson 5.1. Ironically, Lesson 5.1 starts on page 51 today, and you're going to need your book open to that page, a pencil, possibly a highlighter, a calculator for sure, and potentially some graphing paper if you have access to it. Now, if I asked you to count the distance of a horizontal line, right, or a vertical line, how would you calculate the lengths of those two lines? Well, hopefully what you would have said is that you could subtract, you could book, but a lot of times you would just count the boxes to count the length, right? And it's the same kind of idea here when we are going to be starting this particular lesson and looking for distance. Now, the problem is if we have a point PQ, okay, and if we plot those 2 points, it says that P is at 1, 4, Q is at 13, 9. So if we plot 1, 4, here is P, and we're going to label that. And then Q is over here at 13, 9. That's Q. And we connect these two guys. The problem here is, unlike the last problem, is we can't just count these because it's not just vertical or horizontal. We have boxes to count. Okay. So what we have to do instead is we are going to draw in kind of where do these guys meet up. So we're going to sketch in this horizontal line here. And we are going to sketch in this vertical line here. And notice that these 2 points meet up at this new location, which we're going to call R. And R is located at 13, comma 4. Okay, and they want us to make a note of that, 13, comma 4. And on the next page, if you guys flip the book to page 52, they want us to calculate these two lengths. Well, again, I think the easiest method here is just to count, to move from 1 all the way over to the right here at 13. That's a total of 12 units. And to move from R to Q, from 4 up to 9, that's a total of 5 units, right? So we have 12 units and 5 units. And again, all we did was count those horizontal and vertical legs. Well, using that information, we can use Pythagorean Theorem to find the length of PQ. Now, Pythagorean Theorem, for those of you that are not familiar with it, it is that famous little equation here, c squared equals a squared plus b squared. And it's only used with right triangles. And trust me, we'll spend a lot of time talking about that in further units. But A and B are our 2 legs, and then C is the longest side. It's across from that right angle, and it is known as the hypotenuse. So notice in our last page here, we have a right triangle as well at right angle here, and that makes this a right triangle. So we have 12 and 5. Whoops, I drew that a little backwards, but you guys get the idea. We have 12 and 5. So in order to find C, what we would have to do is c squared equals a squared plus b squared, and it doesn't matter which one's a and which one's b. Just C is the important guy. And if we take our calculators, which if you don't have that out, like myself, make sure you get that out. But we are going to type this in. So 12 squared and 5 squared are 25 and 144. Or we can let our calculator do it. 5 squared plus 12 squared equals 169. So c squared equals 169. And then to just get c by itself, we need to square root. So we're going to look on our calculator and we're going to hit square root, second square root, 169, enter, we get 13. Okay, so the length of that segment is 13 units, right? PQ is going to be 13 units long. Okay, now that's all fine and dandy, right? But here's the problem, okay? What happens if we get bigger and bigger numbers? Now, this isn't so bad if we were to graph these 2 points, right? And calculate that. That's where some graphing paper might come in handy in drawing this out. But these guys here get a little bigger. And what happens if we get bigger than that? What if we want to find out a 100 by 100 and the length distance to negative 250, something like that? Okay, what if we want to find that distance? I don't know about you, but I don't want to have to find graphing paper that is quite so big. Okay, so what we're going to do instead is we want to come up with a formula that allows us to shortcut this, and that's where the distance formula will come into play. So what's basically happening with the distance formula for all values? Notice we have this triangle that looks very similar to what we did on the first page, and one points at x1, y1, one points at x2, y2, and they're going to intersect just like we did it at point R at x2 comma y1. So this point's x value, but this point's y value, this point's height, right? So we're going to call that x2 comma y1. And the distance then, no matter which way we look at it, the horizontal distance was what we counted, aka x1 minus x2's absolute value, right? That distance, that subtraction. And the vertical is going to be the similar, y1 minus y2, the absolute value of the x. Remember, distance is always a positive. And if we call this then A and B, okay, so think about this is A, this is B. Together, we would say A squared, aka x1 minus x2 squared, plus, absolute value, y1 minus y2 squared equals our c squared, right? Well, what we said before, though, is that we need to just get c by itself, so we're going to have to square root all of this. And then absolute value is kind of pointless when we square something, because any negative number that you could think of, if you square it, it's a positive. So we don't even have to call these absolute values anymore. We call them just parentheses. And now, we have our distance formula, right? C, or the distance, is going to be the square root of our x values subtracted and our y values subtracted. Now you may also see this sometimes represented where they call this 2 and 1, 2 and 1. Doesn't matter. As long as you stay consistent, it doesn't matter which x value goes first or which one goes second. So I like to just write 1 minus 2. You might see it the other way. Now notice these guys get squared together and then plus these guys squared. Okay, really important that you use your parentheses and everything appropriately. So if you haven't gotten a chance to jot this down, now is a very important moment to do this. If you're confused how we got here, the important thing is you know this distance formula, okay? Now, why is that? Because it's going to make our lives a lot easier to find the distance. For instance, let's test out those points we talked about before, okay? So we had our 2 points here, right? 1, 4, and 13, 9. So what we can do is we can use that distance formula to plug in. So reminder, distance formula, x1 minus x2 squared plus y1 minus y2 squared. All that's underneath our radical. So I'm going to plug in my x values. So 1 minus 13. And then I'm going to plug in my y values, 4 minus 9. And I'm going to be really careful how I type this in, okay? So notice when I type this in, depending on your calculator, if you have a calculator that's older and it pops up with a parenthesis like this, they are not putting this parenthesis right here. What they are saying is all of this stuff coming after this parenthesis is underneath the radical. So you need to put a second parenthesis, and then you're going to type 1 minus 13. You're going to close that parenthesis, and you're going to square it. And then you're going to do plus 4 minus 9, close that parenthesis and square it. And then when you close this, that's saying all this stuff came underneath the radical. And you're going to get that answer that we got before of 13 No triangle drawing necessarily involved. Now, another suggestion I have for you, do the radical at the end. 1 minus 13 squared plus 4 minus 9 squared, and then just take the square root of that value so that you don't mess yourself up when it comes to the radicals, okay? Just a suggestion I have from me to you. Now, officially, it's not going to matter if you would rather do the distance formula or Pythagorean theorem. You are going to have the option, but especially when we're remote learning and we don't necessarily have graphing paper in front of us, or if they're really big numbers, the distance formula is going to be really handy for you, okay? Let's try one more example together. And again, we're going to want to start by writing down the distance formula. I would always keep this handy. X1 minus x2 squared plus y1 minus y2 squared. And then again, we're going to take our two x values, x comma y, 12 and negative 3. And then we're going to take our two y values, negative 5 and 7. Notice I like to go left to right each time. You could flip-flop the order and you'll get the same answer. And then we're going to type this in. Now be very, very careful yet again with this. Notice here, I'm going to shrink this down so we can see everything a little easier. Okay, again, I'm going to start by doing this so that I'm not using the square root so I don't confuse myself. So I'm going to have parentheses 12 minus negative 3 or plus 3. Remember, minus a negative. And then plus negative 5 minus 7 squared. And then I'm going to square root this value, which is 369. And I get approximately 19.2 as my answer. Okay, so 19.2 units. A lot of times I'll just ask you to round to the nearest tenth if you're not going to get a pretty answer. Okay. Want you to try these next two examples on your own. Be very careful how you're typing them in the calculator, and please let me know of any issues you are having. Thanks, everyone.